Hello, so today we're going to be doing LeetCode question 752, called Open the Lock. It's a medium question, and here's the description. You have a lock in front of you with 4 circular wheels. Each wheel has 10 slots, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The wheels can rotate freely and wrap around. For example, we can turn 9 to be 0 or 0 to be 9. Each move consists of turning one wheel, one slot. The lock initially starts at 0, 0, 0, 0, a string representing the state of the 4 wheels. I am given a list of dead ends, meaning if the lock displays any of these codes, the wheels of the lock will stop turning and you will be unable to open it. Given a target representing the value of the wheels that will unlock the lock, return the minimum total number of turns required to open the lock, or -1 if it is impossible. So here we have dead ends as 0, 2, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 2, 1, 2, 1, 2, and 2, 0, 0, 2. And our target is 0, 2, 0, 2. We output 6, which means 6 moves. So here they say a sequence of valid moves would be 0, 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, 2, 0, 0, 1, 2, 0, 1, 1, 2, 0, 2, and 0, 2, 0, 2. Note that a sequence like 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2, 0, 1, 0, 2 would be invalid because the wheels of the lock become stuck here at 0, 1, 0, 2 because that's a dead end. So here, dead ends is 8, 8, 8, 8, target is 0, 0, 0, 9. I just have to turn the right wheel. Here, my target is 8, 8, 8, 8. I'll return -1 because it is impossible. Here the dead end is what we start on, so we can't even move it. And here it says that the target cannot be in the list dead ends. But I guess 0, 0, 0, 0 can. It's kind of weird. So I'll be doing the BFS, breadth first search solution here. So I need a queue and a visited, which is a set. And I'll start off with that one because I've already visited 0, 0, 0, 0, and I don't want to backtrack. And then level is how many turns we've done. 0, 0, 0, 0. And then while loop, so while queue, and then we have a size is equal to the length of our queue, and then a for loop here in range size. I spelled range wrong. So then the next thing I want to do is queue.pop 0. Oh wait, current is equal to queue.pop 0, and then I have to check if my current is equal to my target. I'll just return level, which is like the amount of moves. And if my current is in dead ends, continue, which means I ignore that possibility and I'll look at other possibilities. So if I have, so I'm starting, so if I start with 0, 0, 0, 0, and one of my constraints is 0, 0, 0, 1, and I try that one first. So I try this, and I see that it's in dead end, so I'll try something else, so like 1, 0, 0, 0. So that's basically what the continue, that's basically what the whole continue thing does. And then I want a self helper function, the first one, add children, add child, and I want my current, queue, and visited. And basically this will add all the possibilities from my current. So technically in the first, like if in the first one from 0, 0, 0, 0, this function here will add all the possibilities that I can get using one move from 0, 0, 0, 0. And out of the for loop, we add to the next move, and then if I can't find it, I return -1. And then I define my add children thing. Current is a string queue. Technically it is a queue, but Python just interprets it as a list. Same with visited, even though it is a stack and cannot use append. I don't really know why, but that's just how it is. And for I in range 4, because I have 4 digits, so loop it 4 times. Plus is equal to one of my helper functions, +1, and I need my current and I. And then if my plus is not in, so plus is this 4-digit code, like this next one. If my plus hasn't been visited yet, I mark it as visited now, and I put it into my queue. Plus. Same thing with minus. So like with this plus, if I had like 0009 and I wanted to add something, I can make it 0010 or something like that. Like 1 2 3 3 4. One of the possibilities I could get 1 2 3 5. And I want to do the same thing with minus. Current and I. If minus not in visited, I do the same thing, visited dot add minus, so mark it as visited, and q dot append minus. Whoa. And visited, not whatever the heck I put there. And then next is my other 2 functions, the last 2. So define +1, self s is a string, which is technically current, and I is an integer. And so the first thing I want to do is to check, because if I'm adding and I have like 9 goes to a 0. So first I want to check if my si, so any value, if my si is equal to it's plus, so 9. What I want to do, just type it out first and then I'll explain it. So this may look really confusing, but it's not actually that confusing. So if I first, like for an example, if I had 9999 and I is 2, index 2. So this is index 0, this is index 1, and this is index 2. So I want to split it into these 3 parts. This is the one I want to change. So this s:(I), that means everything before I, not including I. So these 2 9s, adding, instead of a 9 here, because I'm adding, it's a 0 now, and si plus 1 is including the one after I, but not including, but it's just because it's just to the last one. So then once I put it back now, I have from 9999 to 9909 with this thing. And if it was normal, like I don't know, 1 to 2, my temp is equal to the integer of si, and then I just add 1, and then it's the same thing, s:(I) plus, but it has to be a string, so str temp plus I plus 1 colon. Oh, I have to return because where is it? Add child, it wants this, so it returns as a string. So this is basically the same idea. So I'll just explain the differences. first difference, it's 0 because minus 1. So, another example, 0, 0, 0, 0 will go to 5, 0, 0, 9, 0 if my I is equal to 2 and my S is equal to 0, 0, 0, 0. It will output 0, 0, 9, 0. Because, first of all, index 2, isolate this one. This one, turned it into a 9, put it back together, and it's the same thing. And then, else, I just take it away normally, so it's integer si minus 1, and then turn my s colon I, adding my 9. Oh no, adding my string temp plus my si plus 1 colon. Let's run our code, check for any errors. Name visited. Okay. Accepted. And there, accepted. 1264 milliseconds, 15.4 megabytes of memory used. Once again, that was LeetCode question 752. Open the log.